Lesson 10.8 is about the natural logarithm function. So we're going to define it and then be able to use the natural log function. So I'm first going to just read the definition, and then we'll run through some examples. So in advanced work in science and mathematics, the most important logarithm function is the natural logarithm function. Its base is the irrational number e, which has an approximate value of 2.71828. The natural logarithm of x is sometimes denoted by log base e of x, but more often it's written as this, the ln of x. So this is the natural log. It's equivalent to log base e. These mean the same thing, but it's more often written like this. E, like I mentioned, it's an irrational number. It's kind of like pi. It has an approximate value, so 2.71828. Okay. So our examples here, we're going to go back and forth between writing it in log form and exponential form. This is something that you already know how to do. We know that log base a of b equals c is equivalent to a to the c is b. So this one here is in exponential form. You can see that this is in the form a to the c is b. And the directions say go back and write it in log form. So we're going to rewrite this as log. Our a is e in this case. So log base e of b, which is 1092, equals 7. Now, log base e is the natural log, like we just showed on the first slide. So I can rewrite that log base e as just the natural log of 1092 equals 7. And we're not solving anything here. This just said rewrite it in log form. So now this is the same equation in log form. Now if we do the inverse of that, we're given it in log form. So natural log of 100 equals 4.61. That's equivalent to saying log base e of 100 is 4.61. Remember, ln and log base e are the same thing. So now I can go from this form, log base a of b is c, to this form, a to the c is b. So that's e to the 4.61 equals 100. Again, we were just converting it to exponential form there. Okay, directions here are to simplify. So we have the natural log of e to the 10th. Now if I want to rewrite this natural log here as log base e, what we really have is log base e of e to the 10th. Now let's use some of those log rules that we know. We know that when we have an exponent, that's equivalent to writing it as a coefficient. So I can rewrite this as 10 log base e of e. We also know that log base e of e is just 1. Remember, whenever those numbers match, it's always 1. So if we had like log base 2 of 2, or 3 of 3, or 4 of 4, they're all equal to 1. So this simplified answer is just 10 times 1, or 10. Same directions in example form, we're just going to simplify. So first, you might choose to rewrite 1 over the square root of e as just e to the negative 1/2. Remember, the square root is the 1/2 power, and if it's on the bottom, you can move it to the top and make it negative. Now here again, you can apply that exponent rule and rewrite this as negative 1/2 ln of e. Essentially, ln of e, ln and e are just inverses of each other. I mean, we could do the same thing again. We could rewrite ln as log base e of e, and we're just going to get 1. You can think of these as just inverses. They're going to, undo each other, if that makes sense, or reduce to 1. So here, we're just left with negative 1/2. So this example says to simplify e to ln 5. Now, based on what I just said, ln and e are just inverses of each other. So, shoot, this got kind of scratched out. Let me rewrite it here. ln of e to the x is just equal to x, because ln and e are inverses of each other. So with the previous examples, we were dropping down the exponent, and then we knew ln was log base e, but these are inverses of each other. It works the same the other way around as well. If I raise e to the ln of x, that's just going to be x as well, because e and ln are inverses of each other. So if we apply that rule here, e to the ln 5, since e and ln are inverses, we're just left with 5. Again, just to describe what's in this red box here, because they're inverses, whenever you take the composition of inverses, you're just left with x. So in both of these cases, they are inverses because the composition in either order just gives us x. Okay, example 6 is to write as a single log. So let's do part A first. The good news is you already know this. Natural logs are logs. So the 3 rules we learned of logarithms in a previous lesson, I believe 10.5, they all apply here. So if I'm going to condense this to a single log, the first thing I notice is there's a coefficient that I can rewrite as an exponent. So the cube root of 8 is just 2. And then if you notice here, it's ln2 minus ln2. Those are going to just subtract to 0. So our simplified answer here is ln5. So all the same log rules apply to natural logs. Let's look at this one here. It says, what if you have 1/3 ln 8 plus ln 5 minus 2? This is something that we've done before as well. So these aren't all logs, but we can rewrite 2 as a log. So we want it to be a natural log, which remember is log, let me erase that, that got weird, which is log base e, and we want it to be equal to 2. Well, the only way that's going to happen is if you have e squared here. So I think you can agree that that's equal to 2. You would drop down the exponent of 2, and log base e of e is just 1. So really we can rewrite 2 as the ln of e squared, because the ln of e squared is 2. So this is 1/3 ln 8 plus ln 5 minus the natural log of e squared. And now we could condense it. So same rules apply. We would raise 8 to the 1/3 power, which is just 2. So we have ln of 2 plus ln of 5 minus ln of e squared. And then any addition becomes multiplication. So that's ln of 2 times 5, or 10. And any subtraction becomes division. So we have the natural log of 10 over e squared. So that's condensed to a single natural log. Example 7, we're just solving for x. Here's where we're going to go back to an equation you already know, and we've already reviewed in this lesson. Log base a of b is c is equivalent to a to the c is b. So natural logs are logs. So what you want to do is just rewrite the natural log as log base e. Because now you can apply that exponential switch. So I can say e to the 2 is equal to 1 over x. And now I just have a basic algebra equation here to solve for x. So if I want to solve for x, I can multiply by x on both sides to get it out of the denominator. And then to get x by itself, multiply by e squared. So x is 1 over e squared. I'll just leave the exact answer there. You could go to your calculator and get a decimal approximation, but that's fine just to leave your answer right like that. Okay, same idea for this next one. So rewrite natural log as log base e. Okay, now you're going to switch this to exponential form, so that's going to be e to the 3rd equals the square root of x. And now solve for x, just basic algebra. So to get rid of a square root, we square both sides, so e to the 6th is x. Okay, some more solving here. We're basically just going the opposite direction. So now these are given to you in exponential form and you're going to log form. Whereas the previous slide was just the opposite of that. So we're going to go back and write this in log form. So this is going to be log base E of 3 is negative x. So log base E, first of all, is the natural log. And then to get x by itself, we could just divide by -1, so we get negative ln 3. Now this does say use decimal answers, so we can put that in our calculator. I'll show you how to find the button in class if you can't find it, but it's just right on the face of your calculator, and we get negative 1.098. Same thing for the next one. Let's convert it to log form. So it's log base E of 8 is 3x. So log base E is ln. It's the natural log. And to get x by itself here, we just need to divide by 3. So we can go in our calculator, type in the ln of 8, and then divide that by 3. And you'll get about 0.693. Okay, example 11, same thing, we're solving, but notice here that it's not quite in a to the c equals b form yet, because we have this other stuff going on the side of a. So you do want to isolate your exponential first before we do the ABC switch. So I'm going to subtract 2 from both sides. So 3e to the 2x equals 48. And then divide by 3. Divide by 3. Divide by 3. So I get e to the 2x is equal to 16. Now I can start the whole process of I'm going to write this in log form. So log base e of 16 is 2x. And then solve for x by dividing by 2. So that one just had a little bit more work before we could switch to log form. Sorry, I was trying to write at the same time I was talking there. I do want you to rewrite log base e as the natural log. So this is the natural log of 16 over 2. If we put that in our calculator, we'll get 1.386. Okay, example 12 says to solve, leave our answers in terms of e or natural logarithms. Okay. Again, the whole point of natural logs is that they are logs. So the whole process and systems that we learned previous in this chapter are exactly the same. So if you see this one, there's a log everywhere. Natural log, natural log, natural log. So if that's the case, we're going to condense it to a single log on each side. So if I condense the left-hand side to a single log, that addition becomes multiplication. Same as before. I'm not doing anything different from earlier in the chapter. So that's the natural log of x squared plus 3x equals the natural log of 10. Well, if we're saying those two natural logs are equal, this log is that log, well then what's inside here has to be equal as well. So we set x squared plus 3x equal to 10. You can see that that's quadratic, so we'll have to subtract 10 to get it equal to 0. And then factor to solve. Don't forget, just as before, natural logs are logs. So you can't take the log of a negative number. So you can see as if I plugged in -5, I would be taking the log of a negative number. We can't have that. So that's an extraneous solution. And our only solution is that x is 2. One more example here. What if there's just a number that's not in a log? We talked about this early in the lesson. We're just going to need to make it a log. So if that's the case here, and say, okay, these are all natural logs, which is log base e. So I still want it to be a natural log. So I want it to have log base e. So 10 is the same as the natural log of e to the 10th. So I'll rewrite it this way. It's a little easier to see. The natural log of e to the 10th. Remember, those are just inverses of each other. So the ln of e to the 10 is just 10. So ln x plus ln x plus 3 equals ln of e to the 10. Okay, so then you could condense to 1 on this side, so it's x squared plus 3x equals the ln of e to the 10, and now you can set the insides equal to each other. The point is, I just wanted to show you one where you had to rewrite a number as a log. This is ugly. I mean, it technically is a quadratic. You would have to use the quadratic formula for this one. It's not going to factor. But the point is, from this example, that I wanted you to see one more time, rewriting a number as a natural log. Okay, that's the last lesson of the chapter. That's 10.8. So you can see Schoology for the homework there and start reviewing for the chapter test.